Hi Francesc, we are group 41 and today we are going to present the last PLA 1011.
Okay, so here we have the specifications of our PLA. The most important part is the chip right here, which shows how we connect everything and how we will do it.
Okay, so the most important part of our planning is the state diagram of the FSM. Here we see all the states with the flags and the push button, the clocks and everything. We see two clocks with two different speeds to show the numbers in two different ways, and how the FSM will work, the structure right in here. Okay, so here's how our circuit will work, the loop that we'll do, and the ISR. It's the interrupt service routine, which in every phase of our how the logic works, these interrupts can work without a clock rise. Just like in here you see the interrupt service routine and the flags, the play flag and both clocks flags. Then we have the read input with the variable q, which is the counter we saw in the specifications, the FSM logic with all the inputs and its outputs right in here, and its logic to see the numbers in the 7-segment 2-anode display. Okay, so from now on, all the project will have basically the same structure with the corresponding flowchart of the ISR in this case, or the output logic, or the FSM and state logic, and also the truth table, as we can see in here, with all the flags, variables, if, else, cases, switch, and everything else.
Okay, so here we can see a part of our C file, which we adapted and we translated following all the instructions indexes. You can see that it's perfectly notated in our document, and what we want to say is that here you can see that it seems like there is an error because it's in red. However, the problem is in the visual editor, which is not actualized, but the compiler works well and the code compiles without any error.
Here we have the Proteus adapted from Lab 10 to our roulette. Here we have the chip, and here the BCD and the display adapted. Here we have the three states, well, this is just two states of our roulette. Here is the previous bet before press play. We can see that here we have the 0110, 6 in binary, and here in the display we have 06 before start the bet. And then we have a 07, but in fact I take the screenshot and this was going very fast. Here we can see the binary and the display. This is still running until I press the play again, and then we have our final bet. Well, as I said, here we have our final bet, and that was the idea. I press the play button, and when I take my finger out, I have my final bet, reaching the final state that is our bet in binary and the display. Well, here we have the specifications part of our lab part of the PLA. It was divided in 4 steps. The first one is the counter without the retrievable 2. Then is this one, the first timetable. Then we have this timetable that is with the retrievable 2, and then we have step 3 and 4 that is connecting the LCD and measuring the TMR0 and TMR2 wave. Well, here we have the planning and the planning hardware and the planning software of the counter that we made in lab. I'm gonna explain this part quickly, going to the step 3, that is what we did in lab. We spent more time in lab to fit in the video time. So here we have the hardware. Here you can see the LCD, the TMR0, but in the step 4 the only thing it will change is change TMR0 to TMR2 and read the wave that it generates. And here we have the structure, the planning of the software we want to develop. Here, as Jordi said, the state diagram is the most important part of our planning. here we can see how the variables and flags interact with our circuit. Here we also have the truth table, a more intuitive way to see the circuit, and in blue you can see the comments of how we translate the first and second step, how we modify what we have to the third step. You can see how the developing of planning session in the PDF we had with this file.
Okay, so for this part of the PLA, we did the developing and testing following all the steps in Dixis. We simulated the Proteus, we looked at the C files and everything. And the most important part in this case is the prototyping. For doing the prototyping, we did it in different steps. The first step is one you can see here, which is connecting the ground, the VCC, and a duplicated LED, and to see if it works. And you can see in the picture right here that the LED is on. Okay, the next two steps are adding a contrast potentiometer and the LCD screen in order to see what we want to show. And you can see here in this picture that the potentiometer is already put it there, as well as the LCD screen.
So in here we see the LCD display working with the LED bright, and the next step is to connect everything to the oscilloscope to check for the wave and check the waveform application in our computer.
Okay, so to see signals, we added one signal at a time, and we ended up with the three signals you can see here, which are the trigger, the timer out, and the timer zero wave. And you can see here the preparation time, which is 0.5 seconds. And we can also see down here the timing period, which is 3.9 milliseconds.
Thank you, Francesc, for everything.
Thank you, Frances.
Thank you.